Hello and welcome to this WATS how-to video. In this video we will be taking a look at the test step yield and analysis, and specifically the step details view. Now, the step details view has quite a few options to really dig into the data, and what I would like to do is to split this video into two parts. First of all, we will be taking a look at why you should use test step yield and analysis, and giving you a basic overview of how to use the report. And then in the second part, we will be taking a closer look at the step details view to really get to grips with all of the options you have there. So let's find out why we should use test step yield and analysis and where to find it. Here's a few questions, and what they got in common really is they all revolve around the test steps run for a given product or products. Test step yield and analysis is all about determining where in our tests we have problems, and in some cases also why. There's a few examples of what this report can help us determine in the questions. Is there a correlation between when one step is failing and the measured values of other steps? And setting the limits for a given step in a test. Are the limits set up correctly? So let's jump over to WATS. I'm currently located at the login screen and I have logged in, so I'll select the reporting module. And the test step yield and analysis is located under the yield section. Now, normally you might want to take a look at reports like yield report or the product and test yield. These are more high level. So, for instance, starting at the yield report, you can get an overview of where problems occur, and then you can drill down. You will find more about these other reports in other videos and, of course, in our documentation. But in this case, I'll simply enter the test step yield and analysis because I have a product in mind already. So for this particular product, I already have a filter set up. If you would like to create your own filters, you can enter the specific details here and click apply, and then save your filter. So in this case, I'll choose this NIDS filter, and it will pop in some dates and the PCBA test. I'll apply this filter, and it gives me a few products here, so I'll select this one and then click apply selected. Alright, so we get an overview here. We have the top 10 step execution time, which steps takes up the most time in our test, and of course the top 10 failures. So below this we have this long list. These are all the test steps which are run in the test sequence for this particular product, and some basic data here. Of course, if I choose to sort this, sure enough, I will see that the power load have failed the most time, 65 out of 775. And this can also be seen here. So this is the basic test step yield and analysis. And from here we can open the step details view to analyze this further. To open the step details view, you can either click on the name of a step, or you can click on the bar in the chart here. So I'll click on this one because I'm interested in this power load step and why it has failed the most. So I'll click and it will open a new tab with the step details view. And as you can see, there's quite a lot going on here. So let's take a look at the three major parts of this view. At the left hand side we have a step list. Now the step list is very similar to the list of steps which we just saw in test appeal and analysis. There's a few differences and we will take a look at them. But I can, if I would like to view another step, I can simply click it and it will load the data for that step. But for now I'll stay with this power load step. And then we have the header area at the top here, which show us some basic information about run times, about the status of the step, when it was run, etc. We also have this chart here showing an overview of the status. Then below that we have the measurement area, and the measurement area will look at a bit different depending on the type of step. In this case it's a numeric limit test and the data is displayed as a chart. So this chart has a few series. Of course it's the blue line here which represents the data. I can mouse over a single point here and get some data about it. And there's a few straight horizontal lines here as well, and the red ones are the limits, the blue ones are plus minus 3 standard deviation and acts as a recommended limit, and then we have the average, this purple line here. And we can see a few problems here. First of all, we can see that there's a warning here. The CPK is marked in red, and it's easy to see why if you take a look at the limits compared to the data. As you can see, the low limits, there's quite a few steps failing here, and it seems like this lower limit is set too high. On the other hand, the high limits is set way above any data point or 3 standard deviation, and it seems like it's too high. So that's one example of how you can use this report to determine adjustments needed in the limits. Let's take a look at another example here. That's actually from another test sequence, so I'll just open another tab here, and in this case we have this current measurement and it has some failures, and what I would like to do now is to compare this step to another step to see if there's correlation between them. And this is one of the key differences between the step lists and the list of steps in the test appeal and analysis page. In the step list here we can select more than one step, so I'll select this temperature here of the fixture, and as you can see nothing happened on the right hand side. We're still viewing this current, but if I click the Analyze Selected button here, the data will reload. And as you can see, we now have 2 different series here. So I'll close down the step list by clicking this button to maximize the screen real estate. And what I'm interested in is this middle area. We can see that there is a drop in temperature, and as the temperature of the fixture drops, the current measurement starts failing. So this might be worth looking into. Alright, so let's return to our original test sequence. And there is a couple of more basic features I would like to show off before we dive into more details. First of all, right above the chart there are a few options. If I come up to this option called x-axis, I can change this to either time or group line. For the moment we will be taking a look at this time option. So if I choose this, you can see that the x-axis now changed to time, and we can easily see when the data is tested. Now the second thing I would like to show is the grouping. And to properly show this, I will return to my test appeal and analysis page, and I will change my filter somewhat. I will look at a particular part number, and I'll remove the date constraint and apply this. And as you can see, I now have this part number, and it has a few different revisions. So I'll take a look at all of this by clicking this button and then apply this. And I'll scroll down and simply enter the step details. And I will open this group by drop down and simply select revision. And as you can see, we now get one series for each revision. And of course you can apply time to this as well to take a look at when the different revisions was run. In this case it's quite obvious that it's the 8th revision which keeps failing here. Since we are currently looking at grouping, let's also take a look at the final x-axis option called grouped line. If I change this from time to grouped line, each of the revisions, in this case, will get its own portion of the chart. So it's easy to view the data on a per grouping basis. If you want to apply grouping when in analyze mode, you have to select grouped line in order to apply grouping. Grouping will not be available if you select, for instance, line. So that's kind of what I wanted to show in this overview section of the video. And I'll continue on now by taking a more detailed look, explaining each of the options in this view. So let's start with the step list. As we have seen, we can click a name to open it. We can select multiple steps by selecting the checkbox and then clicking the Analyze selected. There also is some basic information here. This is the number of runs and a color-coded status of this step. So if I hover over this, we get some additional information. Then also there is a button to the left of the Analyze selected there. This shows us a list of all the measurements which we have currently selected. So if I, for instance, scroll down a bit here and I click this, we now see that this changed to 2 selected measurements or steps. It's called measurements here because we can have multi-numeric measurements like these. As you can see, these measurements can be expanded and it will load in the measurements. So it's possible to select, for instance, a couple of the measurements of this multi-numeric step. And in this case we have 4 measurements. 2 of those are original steps and 2 of those are these measurements. From this list we can remove any measurements we don't want. We can also, if we would like to see where in the list this is located, we can click on it and then the list will automatically scroll to it. We can also select the top 10 failed measurements. This includes multinumeric measurements, so it will analyze any multinumeric step and load its measurements and analyze those if needed. So if I click this, you can see now that the 10 most failed steps are selected here, and I can of course click Analyze Selected. There we are. As you can see, the measurements are now loaded and we have this yellow warning which tells us that there are some of these measurements which are not numeric steps. If you mix the numeric steps with non-numeric steps, you will get a chart showing the numeric values and the non-numeric values won't be displayed. You can still see all of them in the header, all of the status, but they won't be displayed here. If you want to look at the data for a single non-numeric step, we can do this simply by clicking it. So let's, for instance, take this string test here. And as we can see, this is now displayed as a simple table showing all the measured values. And there's a few of the columns here which is marked in green, and those columns are native to this step type, in this case the string. So if I were to choose, for instance, a pass-fail instead, you will get mostly the same table, but as you can see, you now only have the measured value. Let's return now to a numeric. Where's our power load? There we are. Let's take a look at the rest of the options available for numeric steps here. We have the number of measurements, which simply limits how many measurements viewed. I'll reset that. And then we can choose to filter to show or hide the failed measurements. Then we have the Excel export. There are a few things to note when exporting. First of all, if we choose more than one step, if we analyze, as we can see, we now have the data for both of these. We are in analyze mode as indicated on the top here, and if I were to export this, each of these measurements or steps would get its own sheet. Also, if you apply grouping, for instance, if you group by a revision like we did earlier, you would get one table for each revision. So if you want a single table per measurement, make sure that the grouping is set to none before you export. So those are the basic options, but we also have advanced options. One thing to note about the advanced options is that they don't take effect until you click the apply button. I'll simply return to my original power load step here, and in the advanced options we can edit a few things here. We can change the high and the low limits. We can set the maximum and the minimum measurements which we would like to show, meaning that if I reduce this, for instance, to 12, any value measured above 12 won't be shown. And I can also set the format of the axis here. There also are a few options to be set in the header. You can set the loop iteration and which run you want to view. You can also analyze the chart data further. And lastly, there is this panel showing the selected sequences, which we selected in the step details yield analysis page. Let's take a look at navigating the chart now. Of course, I can zoom into the data by using my scroll wheel, and I can click and pan. And I can reset the zoom by clicking the reset button. This will also reset any edits to the upper and higher limits and max and mean filtered measure, which we just discussed. Then there's the zoom out. Now, when you load a step, WATS will calculate appropriate zoom level based on the limits and the standard deviations. In some cases, this means that there are measurements which isn't shown currently. If you click zoom out, you can see that this measurement located down here was cut off from the view. And WATS does this because if you have measurements which are far out of the normal distribution, it will of course make the details disappear in the majority of the data. Furthermore, we have these checkboxes here which enables us to zoom in only one of the axes. So now I have disabled zooming on the x-axis. And of course I can do the same for the y-axis. So now I'm just scrolling on the x-axis. Also, note that you can enter the UT report for any of these measurements by simply clicking a data point. So if I want to view the UT for this, I simply click it and it will open in a new tab. And it will also scroll to the step which we had selected in the step details view, as well as highlight it. So that's the major areas of the step details, and finally we come to the menu, and the menu is located here in the upper right corner. It's mostly used to tweak how the view works and looks, and I actually have a few of those enabled here already. All of the options are remembered by the view on a per user basis, and this yellowish color tells me that there are options activated there, and we can take a look at those. Setting the chart height is fairly self-explanatory. Edit this. Obviously the height of the chart changes. And then you have the plot line thickness, which is the thickness of the data here. So if I choose, for instance, 3, we can see that the plot gets very thick. Then we have synced charts. This is better displayed if I load for instance, a multinumeric measurement. And if I zoom one of the charts, you can see that the other chart is zooming as well. So as long as this is on, all the charts will zoom. If I turn it off, then return, sure enough, only one of them is zooming now. Then we come to the hide measurement markers, which is currently on as well. I'll remove this, and this will display a circle for each measurement. This is on by default. Note that if you change to x-axis time, it will show these points even though you disable it here, because it's very hard to determine where the data points are in a time view if you don't have those dots. So the last option which was enabled here currently is the hide frequency chart. And if I remove this, and I'll simply right. Now the frequency chart is located to the right of the data chart, and it shows normal distribution. And then we have the compact chart options. If we take a look at the chart options, if I enable this, we can see that the options are taking far less space now. Then we have the maximum series allowed. This is a bit convoluted and has to do with the grouping. Now, as we saw earlier, if I return to a single step here, so if I apply some grouping now, let's just choose time view, and let's group this by revision like we did earlier. And that's working fine. We can take a look at the series here, and we have the different revisions. But let's try to change the grouping now to serial number and group by serial number. And if I do that, I get a warning saying that there will be 3,184 series rendered. And that might be difficult to handle for the browser. So this is really a safety measure to keep the browser from getting performance issues if you choose a grouping which results in too many data series. You can of course change this here if you want to, but keep in mind that rendering thousands of series will probably make the browser unresponsive. Now, the maximum number of series will vary what browser you use. For instance, Chrome is faster at rendering data than Internet Explorer, and the hardware, and of course the amount of data which is rendered per series. But this is a general recommendation. Then we have a similar option here for the data table for non-numeric steps, for instance string limit tests. And if we take a look at any, well, we can take a look at the test sequence. It works just as well for that. So here we have the data for the test sequence. We can see we have a few columns here unique for the test sequence, like the sequence name and the version. And at the bottom here, we have the ability to export to Excel, and we can choose the number of records to show. And as we can see now, it defaulted here to 100. And if you want another default, simply change it here. Then we have a few general options. The decimal format scale. If you choose, let's go back to numeric step here, and choose not serial number as grouping. Let's just remove the grouping. And under the advanced options, as you may recall, we have the axis format. If you set this to decimal, the axis will display decimal values, and the number or the scale is determined by this. This is located under general options and not chart options, because it does affect a few other things as well. For instance, you can see that the scale here is 14.9372, so it's 4 numbers after the decimal point. As stated here, if I change this to 5, you will get a higher precision. Then you have the ability to hide measurement options. The measurement options are the options located above the chart here, so if I click this, you will hide it. Lastly, we have the step list action on analyze. We can set this either to minimize or close, which means that the step list will minimize or close when we click on a step or click the Analyze Selected button in order to maximize screen real estate. So that's about it for the step details view, and as always, if you have any questions, don't hesitate to contact us. Thanks for watching.